Hello everyone, I'm Professor. I'm Yushen Ling, and our group's name is ISLab. I'm going to present our final report. Here is today's outlines. I will first introduce our dataset, then discuss our topic of battle attacks. I will explain how we generated the images and build a federated learning system with convolutional neural network as our base model. Finally, I will present the performance results. Okay, our data consists of PE files with around 200,000 samples in total. The dataset contains around 86,000 benign whale and around 113,000 malware samples. Today's topic focuses on how we perform backdoor attacks. The script modifies a Windows executable in first main steps. Step 1, file resizing. We will expanding we will expand the executable files to accommodate new code and 8,192 extra bytes of space. Step 2, we will create new section. Add a new section named .axc to the executable and config it to be readable, writable, and executable. Step 3, header. We will update the header. Update the file's headers to incorporate the new section. Step 4, code injection. Insert the shell code into the new section and config the new code to execute first at the program startup. After attempting the attack, we analyze them in Cuckoo sandbox for dynamic analysis. We then examine the API code sequence and logs difference between backdoors and raw samples. Our findings show that the the left one is attacked and the right one is the raw data. The attacked files, we found out that it showed successfully file read operation, and it can create and read file .dll files. However, the rows example that it cannot read and create a DLL file, and it reads the target DLL files unsuccessfully. To map the API codes and network traffic into image, we extracted the API codes with timestamp to ensure accurate mapping. Cuckoo Sandbox classifies API codes into 24 distinct categories, and we mapped these API codes to their respective time segments. For network traffic extraction, we use Scapy. During the extraction process, we recorded the timestamps and additional details such as packet size and protocol type for each packet. We also calculated network statistic, including packet count and packet size, within the same timestamp, as well as the frequency of each protocol. After preprocessing, we generated image by combining timestamps from both API codes and network packets. The image will resize to 224 modified 224 pixels, where the x-axis represents times and the y-axis represents categories, which we will demonstrate later. Since the Cuckoo reported times includes environment setups, timed and contains substantial idle periods. We created a unified timeline by compressing it to remove escapes. So we defined the categories mappings where each categories will assign a specific role and color. The metric is like this table, showing in like this table. So we implement federated learning with convolution neural network as our base model, consisting of three convolution layers, and these are our parameters. Then our model achieved the following results. The first one is better attack, and the last one is without the attack. And here is our reference. So thank you for listening.